Welcome back. In this next part of the lecture, we're going to talk about inverse cosine and inverse tangent. So a lot of this is going to be repetition of what we already did when we talked about inverse sine. That for both of these, we'll have to restrict the domain. And so really what's going to be different here is just what is our restricted domain. If you're thinking about the graph of cosine of x, we know what the graph of cosine looks like. There we go. There's one full cycle of cosine of x, and you can see that if we were to just restrict our domain from 0 to pi, then that would be exactly a one-to-one function, because what would be on our graph would be just the points where any horizontal line would cross through our graph in exactly one place. You might be wondering, why aren't we using the same restricted domain as we did for sine? And the reason we're not, of course, is if you used the same restricted domain for sine, number one, that's not a one-to-one function. That's what cosine looks like in that little interval. And you also don't have all the y values that cosine has. You only have the positive ones. That's the reason why for this we have our restricted domain being from 0 to pi. That will give us all the possible y values for cosine from -1 to 1, and make it also be a one-to-one function. The notation, same sort of thing as before. I could write cos inverse, or I could write arc cosine, and that they both mean the same thing. And of course, the inverses do exactly the same thing as before. If you know that for cosine, when the input is pi over 4 radians, then the output is √2/2. Then for cosine inverse, it does the reverse. If the input is √2/2, then the output is pi over 4 radians. And again, for inverse cosine, as well as for all the other inverse trig functions, the angle that we get as our output is given in terms of radians. And then again, same thing that we had before. We have our graph of cosine, and any points that we have on the graph of cosine. So for example, the point 0, 1, you have an equivalent point on the graph of inverse cosine, this point 1, 0. Or this point here, which is pi over 2 comma 0, that gives us the equivalent point 0 pi over 2 on the inverse cosine function. And as usual, the function and its inverse switches domains and ranges. So for cosine, the domain was from 0 to pi, and so for cosine inverse, the range is from 0 to pi. For cosine, the range was from -1 to 1. So for cosine inverse, the domain was from -1 to 1. Okay, so we're going to do some finding the exact values of trig functions, and or inverse trig functions rather, and if we can't find the exact value, then we'll need to use our calculator. So give the exact value if possible, and if an exact answer is not possible, then we can give our answer rounded to 3 decimal places. The first one, I mean, we could answer actually the first two just thinking about the graph of cosine. Which angle is it that gives us a value for cosine that the output would be 0? Or in other words, what is the angle where cosine of an angle is 0? If you're going back to your previous graph, you know that cosine of pi over 2 is 0. We know that cosine of pi over 2 is 0. That means cos inverse of 0 should be pi over 2. Similarly, arc cos of -1, we're wondering what angle gives us a value for cosine of -1. And if we're thinking back to our restricted domain, when x is pi, the y value is -1. We had that point pi -1 on our graph of cosine. So we know that since cosine of pi is -1, then arc cosine of -1 is pi. Let's do another one here. Cosine inverse of negative root 2 over 2. If you're thinking back to your special triangles, we know that if we're using the 90, 45, 45 triangle, that if you were interested in something like what is cos of pi over 4, you would get adjacent over hypotenuse, which when you write it in simplest terms would be root 2 over 2. And that's close to what we want. We want cos inverse of negative root 2 over 2. So we want to know what angle is it that cosine of the angle gives us negative root 2 over 2. Now, of course, remember that for cosine, the domain that we're restricted to is from 0 to pi. So our angle has to be somewhere in this vicinity, in quadrant 1 or quadrant 2. But we also know that it can't be in quadrant 1 because cosine would be positive there, and we're looking for cosine to have a negative output. That means that we must be in quadrant 3. Quadrant 3 where sine is positive, but everybody else is negative. So if we were thinking about the root 2 over 2, that came from 45 degrees, or pi over 4. So negative root 2 over 2 should come from 3 pi over 4, or in other words, 135 degrees. We know that cos of 3 pi over 4 should be negative root 2 over 2, and so that means cos inverse of negative root 2 over 2, that is 3 pi over 4. All right, and then the last one that we have here, cosine inverse of negative 0.2. This is one where it's not something that comes from either cosine being thought of as the x-coordinate in a unit circle, or in terms of adjacents and hypotenuses in a right triangle. There's not a really good way to get this number of negative 0.2. So for that, I will use my calculator, and I found that when I enter in, again, making sure that you're in radians mode, second function cos negative 0.2, I get a value of about 1.772. And of course, this is a measurement in radians. So I'm not saying that cosine of 1.7 degrees is negative 0.2. It's cosine of 1.772 radians is negative 0.2. So cosine inverse of negative 0.2 is 1.772 radians. I'm only writing the word radian there just because I want us to be really super clear that when we're talking about trig functions here in Chapter 8, we're thinking about the angle always being in terms of radians. Of course, it's totally fine for you to just give your answer as 1.772, because angles measured in radians don't have to have the units written next to them. We could just say 1.772, and it's understood that we're talking about radians. Now, same sort of thing that we had from before, where if you're thinking about cosine composed with cosine inverse, or the reverse, cosine inverse composed with cosine, if we're thinking about values that are inside the domain, so if x is in the domain of cosine inverse, then cos and cosine inverse cancel each other out. If x is not in that domain, then cosine inverse is undefined, which makes cosine composed with cosine inverse undefined. If you're taking an angle in the restricted domain of cosine, then that means that cosine inverse composed with cosine of that angle, those two should just cancel each other out. But if you're talking about an angle that's not in that interval from 0 to pi, cosine inverse is only going to give you outputs that are in that interval, so we'll have to do the same sort of business about thinking about reference angles and who is the angle that has the same reference angle as the one that we're interested in, but happens to be between 0 and pi. So let's take a look at some examples here. So for the very first one, we're doing cosine of cos inverse of negative 0.87. And that for sure is inside the domain of cos inverse. Cos inverse is defined for -1 to 1. So that means that cos and cos inverse should cancel each other out, and we should just have -0.87 as our answer. Same thing with the next one, cosine inverse composed with cosine of 3 pi over 4. 3 pi over 4, of course, we know that that happens to be in quadrant 2, and that is definitely in that from 0 to pi intervals, so we are in that restricted domain for cosine. So that means cosine inverse of cosine of 3 pi over 4, that the 3 pi over 4 will be what's left, because the cosine inverse and the cosine will cancel each other. Now for this next one, cosine inverse of cos of 7 pi over 6, which if I were to just draw my angle here for a minute, this of course, this is pi radians, or 6 pi over 6 radians if you wanted to think about it that way. So 7 pi over 6 should be just a little bit past it. And it should be past it by pi over 6 radians. So the angle that we're talking about has a reference angle of pi over 6. Now, if we're thinking about is cosine positive or negative, in this quadrant, cosine is negative. Now, we are restricting cosine to being in quadrants 1 or quadrant 2 when we're thinking about defining our inverse cosine function. So inverse cosine is only going to give me an answer somewhere between 0 and pi. It will not give me 7 pi over 6 as my answer, because 7 pi over 6 is not inside that interval. So I'm thinking here, well, cos of 7 pi over 6 is negative, and in quadrant 2, cosine is also negative. So if we took an angle in quadrant 2 that had the same reference angle of pi over 6, and again, if all of this is 6 pi over 6, then that means that this angle should be 5 pi over 6. So one thing that we've just discovered, we've discovered that cosine of 7 pi over 6 should be equal to cosine of 5 pi over 6. The reason being is that they're both having a reference angle of pi over 6, and that they're both in quadrants where cosine happens to be negative. Okay, so that means that when we take cosine inverse and compose it with cos of 7 pi over 6, cos of 7 pi over 6 will give me some number, and that number, cosine inverse, will take that and return it as 5 pi over 6. It'll give me the equivalent angle in quadrant 2. And then last one that we have here, cos composed with arccos, or cos inverse, of 1.57. And that's not inside the domain of cosine inverse. So since we have that this is undefined, that means cosine composed with it is undefined as well. One more here. We've got cosine inverse composed with cos of 7 pi over 4, which, if we're looking at 7 pi over 4, or 315 degrees, that would have reference angle of pi over 4. And in that quadrant, cosine happens to be positive. So if we're thinking about another angle that has reference angle of pi over 4 and is in a quadrant where cosine is positive, that would be pi over 4 in quadrant 1. We know that cos of 7 pi over 4 will be positive, and cos of pi over 4 will also be positive, and that they both have the same reference angle, so they should both be equal to each other. And so cos inverse will not give me 7 pi over 4 as my output, because 7 pi over 4, that's not in the restricted domain for cosine. However, pi over 4 is, and that's what cosine inverse will give me as my output, pi over 4. For tangent, much the same. Again, we're restricting our domain from negative pi over 2 to pi over 2. You might notice here that it's not square brackets as it was before, it's round brackets. So we have from negative pi over 2 to pi over 2, not including both of those. And the reason, of course, why we're not including negative pi over 2 or pi over 2 is because pi over 2 and negative pi over 2, that's where you have vertical asymptotes. You had vertical asymptotes of positive pi over 2 equal to x, and negative pi over 2 equal to x, if we're remembering our graph of tangent looking a little something like this. So, of course, we are not going to be able to include negative pi over 2 or pi over 2 in our domain for tangent. So we have a restricted domain similar to the restricted domain for cosine, or sorry, for sine rather. Sine was from negative pi over 2 to pi over 2, including both endpoints. Tangent is from negative pi over 2 to pi over 2, not including both endpoints. And also, same as before, we could call it tangent inverse or arctan. So there's a nice little twist here. As opposed to the other trig functions that we had, sine and cosine, as opposed to them, they had for sine, it was a restricted domain and also a restricted range. The range was just from -1 to 1. Same thing for cosine, restricted domain and also restricted range from -1 to 1. But for tangent, although it's a restricted domain, the range is all real numbers. And that means that for tangent inverse, the domain would be all real numbers. That's something that's sort of unique here, because for sine inverse and for cosine inverse, those had restricted domains because sine and cosine had restricted ranges. All right, so let's take ourselves into the next part where we'll do some calculations. Only one thing just to mention here, of course, which is, as always, when we're thinking about the relationship between our graphs and our inverse functions, that they're switching anything x and y related. So we have, for example, the point pi over 4, 1 on the graph of tangent. You would also have the point 1 pi over 4 on the graph of tangent inverse. And that since tangent has vertical asymptotes, x equals pi over 2 and negative pi over 2, then that means tangent inverse has horizontal asymptotes, y equals pi over 2 and negative pi over 2. So for these, we just need to, again, find our exact values when possible, and when not possible, using our calculator. So tangent inverse of 0. I know tangent of 0 is 0, so tangent inverse of 0 is also 0. And that could be confirmed just by looking at the graph itself. If we know on our graph we have the point 0, 0 for tangent, then we'd have the point 0, 0 for a tangent inverse. There we go. For the second one that we're looking for, tangent inverse of -1, this would be something, again, where if we're remembering in our graph what we had on the previous slide, you know that for tangent of -45 degrees, negative pi over 4, that would be -1. And you can confirm that by, number 1, thinking about using your special triangle. So tangent of 45 degrees should be opposite over adjacent, or 1 over 1, which is 1. And so then tangent of negative pi over 4, or negative 45 degrees, should be -1. And again, you could see that on the graph on the previous page. You have that when x is negative pi over 4, the y value is -1. So that means then that for our graph, for our arctan of -1, tangent inverse of -1 should be -pi/4. Tangent inverse of -√3, this one, if we're not remembering it right off the top of our head, √3, remember that showed up in our 30, 60, 90 triangle. And if you're thinking about tangent as being opposite over adjacent, you know that for tangent of pi/3, that should be √3/1. So we know tangent of pi/3 is positive √3, so tangent of -pi/3 is -√3. The reason, of course, why you could think about this relationship, you could think about it in terms of quadrants, or you could think about it in terms of tangent being an odd function. Tangent of pi/3 is positive √3, so tangent of -pi/3 is the opposite, negative of √3. Either way, once we've found that tangent of -60 degrees of -pi/3 is -√3, then tangent inverse of -√3 is -pi/3, -60 degrees. For tangent inverse of 807, that does not come as a number from any nice special triangle, so there I'm going to use my inverse trig functions, making sure I'm in radians mode, then second function, tangent, and then 807, and that is about 1.56955, so that would round off to 1.570 if we're rounding off to 3 decimal places. Now, for composing trig functions with their inverses when it's talking about tangent, nicely, because tangent inverse has all real numbers as its domain, then no matter which number you pick, tangent composed with tangent inverse would just give you x, that they would cancel each other out. We don't have the option of tangent inverse ever being undefined because it's defined for all real numbers. The same problem that we had about, well, what if we composed tangent inverse with tangent, as we did back in cosine inverse composed with cosine or sine inverse composed with sine, we will have to think about the fact that tangent inverse has only limited outputs. Tangent inverse gives you outputs between -pi/2 and pi/2. And so if your angle is between -pi/2 and pi/2, then tangent inverse will just cancel out tangent. But otherwise, we'll need to do the same sort of business that we did when we were composing sine with sine inverse or cosine with cosine inverse. So for the first one, this is the easiest one. This number, -123.45, whatever that number is, it is in the domain of tangent, which means that tangent will cancel out tangent inverse, giving us -123.45. So because this number is in the domain of tangent inverse, then tangent will cancel out tangent inverse, leaving you just with that -123.45. For the next one, pi/10, that's in the domain of tangent, so tangent inverse and tangent will cancel each other out. That'll give me just pi/10. For the next two, the angles that we have, 3pi/4 and 4pi/3, neither of them are in our little restricted domain. So if we're thinking about 3pi/4, that has a reference angle of pi/4, and in that quadrant, tangent is negative rather. Sine is the only thing positive in this quadrant, of course, and cosecant. So if we're thinking about the fact that tangent is negative, and of course tangent's restricted domain is from negative pi over 2 to pi over 2, then the equivalent angle in that restricted domain would be negative pi over 4. Negative pi over 4 would have the same reference angle. It would have a reference angle of pi over 4. It would also be negative for the value of tangent. So we know that tangent of 3 pi over 4 and tangent of negative pi over 4, that those are equal to each other. And since negative pi over 4 is inside of my restricted domain for tangent, then negative pi over 4 is what I'm going to get out of this composition. And I'll do the same thing with the last problem that I've got here, tangent inverse composed with tangent of 4 pi over 3, where, again, if we're thinking about where is 4 pi over 3, it would be in quadrant 3, where pi over 3 is the reference angle. And in that quadrant, again, we're thinking about, is tangent going to be positive or negative? Well, in that quadrant, tangent is positive. And if we're thinking about, well, what would be the equivalent angle in a quadrant where tangent is positive? Well, that would be in quadrant 1. And in quadrant 1, the angle would be pi over 3. We know that tangent of 4 pi over 3 and tangent of pi over 3 should both be equal to each other. And of course, that's because they both have the same reference angle of pi over 3, and they're both in quadrants where tangent is positive. Since pi over 3 is in that restricted domain for tangent, then pi over 3 is what I will get as my output.